Hi everyone, in the previous video we implemented a vanilla rack system and we discussed its shortcoming and a strength. Even though we employed the RAPTOR architecture, which has a nice property of combining details with holistic picture, and still it could not answer all sort of questions. In this video, we will try to address that with using knowledge graph. In addition to the introduction that we had in the previous part, we need to know about two more things, graph and GraphDBMS. For the graph part, I have brought 3 resources here which are great. I'm currently taking pleasure of reading these graph databases for dummies, and they are free, available by Neo4j, and also there's a great video that you can check that out later. And for the GraphDBMS, I'm using Neo4j, and we need to know a couple of things about this. So we can easily create a blank project on sandbox.neo4j.com to host our graph database, and we can also send query and interact with this GraphDBMS publicly available, and it is free. And then for this purpose, you need to get your credentials so that you can connect your Python code with your GraphDBMS hosted on sandbox.neo4j. And once you have everything set up, you can also come here and visualize your graph and play around with the nice GUI that Neo4j is providing, Neo4j browser, by clicking open here. That's pretty much everything about the introduction that we need for this part. About the project management, we have already covered the details in the previous part. If you want, please check that out. In the third part, we need to install the previous libraries as well as a new library called Neo4j for our graph database. Okay, right now they are imported. It took 45 seconds, and then we don't have mylive.py, but once we uncomment this line and run that again, it will write this cell into mylives.py file so that we can later use that. And everything else is like the previous video, the fourth part, handling data. You just need to run all of them, and we don't have anything new in the modeling part. For now, we are going to implement KG shortly. And for the evaluation part, we have discussed that before. And deployment, right now we will get into the driver function which will put together everything. Alright, the 7th part. First of all, you need to upload a couple of files from the dataset folder on my GitHub repository, and then we are good to go for unzipping the file and also running the rest of the code to one more time load the previous rack system that we implemented, and then we continue on top of that. So let me run the first cell to unzip the txt files, each of which contains the information of each session, or you can think of that as a document. And then we will continue by establishing the connection to GPT-3, to OpenAI to use GPT-3. Alrighty, I import my result for my RAPTOR model. I don't run the code again. I have already pickled the result. I create an instance of my VectorDB and store all of the documents as a vector in my VectorDB. And then right now we can query our model, our vanilla rack system, to see the performance. Actually, we know that it fails on the second and third question. How many sessions did Laura speak at? Topic discussed, actually it is query 2, so let me change this. It was still passing query, but we need to pass query number 2. Let's run that again. Laura spoke at 2 sessions, which is incorrect. And how many sessions did we have? There were 4 sessions held at invention. Yeah, it is absolutely incorrect, and we know right now the reason. Wait a minute, where did I exactly get this idea of using graph for improving the performance? Actually, my thesis is about using graph in large language models for text summarization and improving their performance. And I also had some studies on recent papers about using graph for factual consistency and also in rack systems. And for the implementation part, I consulted with my experienced friends in this field. And the second question that we need to answer is, why did I use Diffbot API and not anything else? Actually, it was free and it has a nice documentation comparing to ChatGPT, which is not free, and you have to pay a lot of money for this simple case. As we talked in the introduction, we need to host our graph somewhere on the internet or on our local systems. And I have already created a blank project on Neo4j, and I'm using the credentials that I have here to connect to this database that we have here. And so I will run this cell and it will establish a connection to our GraphDB. And for extracting the entity and relation, because knowledge graph consists of entities and the relation between them, and each entity or relation might have different properties or label, and we can use an off-the-shelf tool for this purpose, for extracting knowledge graph out of the documents that we have here, and I'm using Diffbot for this purpose. So I have already ran this code and stored the result in Inventor's graph pickle file. And so I will run this line and then load my pickle file. And actually Diffbot will generate a graph representation of each of these documents that we have, which means it will extract nodes, entities, and the relationship between them. So here we have David, and also it has a nice feature, the Diffbot, that it will link that person to their or entity or an organization to their Wikipedia page and add meta knowledge or metadata. So this is the graph structure that we have for the 6th document. Let's run the code and see the graph schema. We have different type of nodes: person, organization, location, award, scale, and the relationships. And we have relationship properties and the rest of the schema. So let's query the dataset and return the node, and we'll limit that to 1, which means we return the first node. So it returned Laura, and it has got some meta knowledge for Laura, and the position held is correctly identified. Laura is a chief executive officer, and let's see that page. Yeah, so it has a nice feature, and it is quite fast for extracting relationships and nodes. The next part is creating an instance from our GraphCypherQ&AChain. The chain is, we ask a question, and then the chain will convert that question to our to a language that is made for our database management system. In this case, we are using Cypher for querying the graph database. And the next part is, so let's see this example. We ask a question: who are the people working in the same company as Laura does? And then our question will get converted to a query in Cypher language, generate Cypher. And then we return the answer of that query, the result of that query, as the context for our final answer. And the final answer would be based on this context that we have got from the knowledge graph, and then we use a language model to explain that. So we have 2 parts. We need a model for converting our query in English to a language made for that graph DBMS, and then we use a model to explain that. And also, obviously, we need to pass our graph as well. So let's ask this question: who are the people working at the same company as Laura does? It has generated the Cypher query perfectly well, and it has got some results, but we are not sure. We have to double check, and we have to double check that because we already have the graph here. We can go and refer to the graph, and if we want to be nitpicky, and we have to sometimes be, we can refer to the original documents that we had. In venture session, we can go to the website and check that, or the txt files that I have extracted from that website. So let's open by clicking on this open browser, you get a nice GUI for interacting with the graph. So as you can see, we have a word, location, organization, person, and a skill. Let's visualize that, call db.schema.visualization. Okay, this is the general schema of our knowledge graph. We can also return the whole graph by returning all the nodes and all the relations, and it will visualize the graph, but you have to keep in mind that it will only visualize the first 300 nodes by default, but you can change the settings to get the whole graph. So we will use that later for checking the correctness of the result that we have got here, but let's go ahead and continue. Okay, let's continue with the questions and go to the next question and ask how many sessions did Laura participated in. If you run the query question, it will query the dataset, and the query generated is match person named Laura with relationship named as work relationship to person, return the count. So it doesn't generate the query well. The query is not correct, and the answer is not correct as well. So let's go to the next part and ask about the 3rd question: how many sessions were held at this event? Hold, session, event name. So it tries to match event with name, event name, but it doesn't. It's not correct because it doesn't have any event name. It's inventor. It's called inventor. But maybe the question is not perfectly formulated. Let's change the question to how many sessions did we have? If we change the session question, so it seems that it could not run. It could not generate an appropriate query based on the schema that we had. So we will discuss this later. So let's fact check the first question. I went to the graph and I was seeing who are the people connected to Alberta Innovation Organization, which is the company where Laura is working. And I saw one person, David. Well, I was not quite sure if David has anything to do with Alberta Innovation, and I think he's not an employee. So I checked the relationship, and it was an employee or a member of, but I was skeptical. And the evidence for this relationship, as you can see, is name Brandy Old, who has a position technology development advisor at Alberta Innovates. So it has got an evidence for David, but this evidence is for Brandy. So let's go to the documents and see why we have got this incorrect entity and relationship between David and Alberta Innovation. David obviously is not working, and if we go through the documents and find the document that is talking about David, we see that we have in document 14 we have a session. There is a file in which we have this content, a session under the category of entrepreneurship, which is titled as David Bland Testing Business Ideas is held at Inventure. The description of this session is David Bland, the man who literally wrote the book on testing business ideas. Okay, so we have this session, and the session speakers are Brandy Old, who has a position technology development advisor at Alberta Innovates, and then the second person is David Bland, who has a position founder and author at Precoil. So it has mistakenly got Alberta Innovates for David. Let's go to the sessions on Inventor's website. So David is here, but since his name is close to Alberta Innovates, the Diffbot API mistakenly has associated that with David, which is the reason that we have this wrong entity relationship between Alberta Innovates and David. So the query is generated well for the first question, but the answer is not correct, and we have factual incorrectness in our graph, which were supposed to help us in improving the performance and factual correctness. So let's go to the second question. For the second question, if we read our question, is inquiring about number of sessions in which Laura was a speaker, but we don't have any session label here in our graph. We have a word, location, organization, person, and a skill. Why? Because we use the off-the-shelf tool for creating a knowledge graph, and we didn't provide any schema. So we should not expect that our knowledge graph do a magic and figure out, okay, so we have to also generate a label for sessions, and we have to name them and get their name as a property for that session node. So we cannot expect that. We use Diffbot, and they came up with this schema with the labels of the nodes. So if we don't have the correct schema, we cannot inquire the graph about the number of sessions. So if we want to ask about the sessions, we have to create a session node type so that we can later go to the graph and search for that easily. Let's see what is exactly wrong with the third question. The third question is, how many sessions did we have? Again, we have the same problem. Our off-the-shelf tool for generating knowledge graph came up with this schema, but if you are going to ask about the session, you have to generate one label for the session based on the documents that you have, because obviously we have this information in our graphs. We have session and the category name, we have the description of the sessions and people that they are speaking with their position and the company in which they are working. So we have this knowledge, but we didn't leverage that. And you might ask, okay, Reza, how am I supposed to come up with a schema and designing my knowledge graph? And the answer is, it depends on your use case. If your use case depends on inquiring about the number of sessions, their title, the relationship between people and categories and sessions, you have to have this schema defined before querying about that. When everything you have got is a hammer, you see every problem as a nail. It is so true. At the beginning, to address the problem that we had with the previous tool that we used for generating knowledge graph, I tried to use GPT-4 Turbo, and I was trying to prompt that in a way that it can extract the session category type and session title, and then associate or put this session description as a property for the session node, and then it create person, which has a property of role, and a company which is related to that person. I was prompting GPT-4 Turbo to extracting this information, and I thought, wait a minute, the problem is super simple, and probably using any language model for that is an overkill. Why not just, we already have scraped the website, and we have exactly and clearly the category types, the category type that we have here, session title and description, and also name of the people with their description. So the only problem that were left was extracting the position and the company name, and I noticed that there is a pattern here, which is very simple. People have their position, and then we have at the company. So if we split the description of the people by using at, we can extract this information super simple with 4 lines of code and no problem. But there was a little bit problem and exceptions. Some people didn't have any description, some people they only had their position. I added a couple of if statements to handle this part. So it's so true that we always try to use large language models for everything, but sometimes it's not necessary. All other parts of this notebook, the 4th notebook that I have improved the knowledge graph creation, is exactly the same as what we had before. So just run the parts that we had, and then we get into setting up the improved knowledge graph. For setting up, I have already got another blank data set to host our graph database, and we can establish a connection to that. Then we set some constraints over our schema. The way that I designed my schema was based on the questions that I was interested, or the people that are going to use this tool are interested to ask. They are probably going to ask about category, the relationship between category and sessions, and the people who speak at the session. So based on this information and the use case that we have, I designed the schema. And I put constraints, a couple of constraints on category, speaker, and company for the uniqueness of their name, and then extracted the position information and created the graph. And the graph is already hosted here. We can go and play around with the graph here. So let's log in, and here we are. We have category, company, session, and a speaker. And our speakers, each of which has position and attribute for them. And our sessions also have their description here. We can later use that if necessary. And if we visualize the whole graph, we have a nice representation of our graph. We have sessions, speakers, and you can also play around with this graph that we have here. It's a little bit cool. So sessions have a directed edge to a speaker named session has a speaker, and each speaker has a relationship with companies, and the type of that relation is speaker works in, and we have category. So this schema was good enough for answering the questions that I was interested to ask, like how many people are working in the same company as Laura does, or how many sessions did Laura speak at, and then so we add all of the information to the graph, and then we can print the schema and then go to using the knowledge graph for answering our questions, the question that we had. For using the new generated knowledge graph, we need to establish the connection, and then we define our cipher chain, and then we get into asking the questions. Who are the people working in the same company as Laura does? So I asked the question and then went and double checked and fact checked the result, and they were all correct because the query is generated correctly, and also the speakers were all generated associated with the companies correctly, because we were not using a Diffbot API or ChatGPT that might extract incorrect relationships or label the nodes incorrectly. We use a Python code to simply extract the information that we already had and put them for category, session, company, and speaker properties, and then we draw a connection between them. So let's go to the second question and ask how many sessions did Laura participate in, and we got the result of 0. The reason is we had, if you remember the graph, we had the label session, node session, and the relationship between them was a directed relationship from session to a speaker with name session has a speaker. But the query that is generated, the cipher query, is reversed. The relationship is not between speaker and session. It is from session to a speaker. So it couldn't get that right. That's why I tried to address that by passing the schema. And I asked the model to carefully generate the query based on the schema. How many sessions did Laura participate in? And the answer was 6, and it was correct because the knowledge graph was generated correctly, and also the query is correct. We have session connected to a speaker, but previously we had a speaker to session, which was not correct. And the last question is how many sessions did we have? If we run the query, we get 186, which is exactly the number of sessions that we had in our knowledge graph. All right, so far we have talked about querying the information and retrieving the information with knowledge graph, and also we previously saw how to use RAG for retrieving documents. How about combining these two, combining knowledge graph and also RAG, or in another word, enriching the RAG result with knowledge graph? So it works well in most of the cases, but we have to carefully, and this is the thing that nobody talks about, and I saw a couple of articles and some tutorials, they all try to, at least as far as I felt, they try to hide that. But there are some limitations that we have to carefully take care of that. Like, what if the information fetched from RAG and knowledge graph, they are irreconcilable? So we have to carefully prompt the model to generate the final answer based on the knowledge graph if there is any inconsistency between the information that we have got from RAG and knowledge graph. If you remember, RAG told us that we had only 4 sessions, but in our knowledge graph, when we asked with knowledge graph, we got the correct number of sessions. So this is something that we also need to take care of that if you want to use RAG enriched with knowledge graph. And the last part is having a UI with a streamlet. Since I have ran this code in the previous part, I'm not going to run this again, but feel free to run this code and play around with the nice UI of streamlet. And finally, the most important part, conclusion. So we faced a problem at the very beginning that we couldn't answer everything with a vanilla RAG system, and then we implemented a KG knowledge graph, and for that we used Diffbot, a tool, but that was not generating the knowledge graph perfectly. So we tried that to avoid this off-the-shelf tools and probably use a better tool for generating that. And I was inclined toward using ChatGPT because most of the people are using that, especially it seems that GPT Turbo 4 is capable of generating node entities and relationships perfectly, but it has also sometimes some disadvantage, like generating hallucination and generating incorrect information. So I was trying to prompt that for my case, but I realized that it's an overkill, and I can simply with 5 lines of code extract the node entities and the properties of them and the relationship between them. So this is about the important part as to how I generated knowledge graph. The third part is about how to query your knowledge graph. So a schema is important and allows you to have an idea about the information that you have stored, and also have an easier time when you are writing a query. And when you are asking your question, you better be aware of the schema, because if you don't have, for instance, if you ask what would be the favorite food of favorite dish that Laura likes, so knowledge graph is not able to answer that because we don't have such an entity or relationship or information in the graph. So you have to be aware of what is exactly stored and the general idea of the schema. And you better pass the schema and the relationship directions and types to the language model that is generating the query for you, because we have automated that. We ask question in natural language, in English, and then we pass that to language model to generate the query, the graph query for us. And yeah, we talked about this part. If the only thing that you have got is a hammer, you see everything as a nail. It's so true. And when you have a RAG system enriched with KG, you have to take care of those times that the information are irreconcilable. But we haven't finished yet. We have an important task to do, which is localization of all of the things that we have done here. So stay tuned.